Everybody, we're group 3. It's volunteer computing. My name's Derek Bennett.
Jack Delaney.
Brian Horst. Brian. David Asseltine.
And Christopher Crowder.
Hey, and our goal here is to develop a volunteer computing system for WVU. And what volunteer computing is a process of taking small or large amounts of data and breaking them into small packets, so where they can be distributed over many volunteer computers to get results in faster time. Volunteer computing has the potential to further research that requires great computational power at a relatively low cost. And the proposed volunteer computing network that we want to get developed here at WVU, we hope to use for wireless communication networks and other types of research here at WVU. Recently, in March 2008, WVU was awarded a grant to the National Science Foundation. And what the abstract for this grant states is that we provide researchers with a grid-powered service via web portal interface. And web service will enable rapid execution of computationally demanding PC simulations. And this is necessary because compute-intensive simulations are essential to the progress in the various fields of which it would apply. The computation requirements often exceed available resources, but all of the largest institutions. So right now, like if you were to get any kind of computational data over things, it's really expensive. So we're trying to get a system that would be relatively cheap or even free.
Alright, yeah, so our goal is to create a network at WVU that uses volunteer computers. Right now they have a system that sort of does this, but there's a licensing fee for a computer, and we want to kind of get away from that so we can get it on as many computers as possible, as cheaply as possible. We want it to be easy to use for everyone. We kind of want to have our web interface work like Gmail, where researchers can just log in, they can see things that are running, maybe have a little progress bar, show how far along things are, really easily manage and get their data. We want to have incentives for researchers, say if they have a lab or something, they can connect their lab and add it onto the grid and add more power. And then we can credit that later when they want to run a dog web system.
These are our requirements. Marketing needs to be available to as many people as possible, both researchers and volunteers that want to add their machines to the grid. So people running different OSs or whatever, they can all install the client to contribute to the grid. And then researchers should work with all browsers so they can get on, submit their jobs, and see the results. Different user levels, so have an administrator who handles everything, and then researcher users will be able to add jobs and view the results, and then the volunteer users will be able to see things on the web as well. It needs to be user-friendly, obviously. It needs to be scalable. We're starting with probably a handful of volunteer computers and maybe 1 or 2 researchers and jobs, but this should be able to go to dozens of researchers and hundreds of thousands of computers on the grid. The volunteers should be able to control how their machine is used when they're contributing to the grid. So, say they only want to contribute on weekends, or they can set when they're contributing. Researchers should be able to do job submissions through the web interface. And the administrator should be able to control job scheduling, but also anything through the web interface. They said compatible with operating systems and browsers so everyone can use it. We'll have a server that controls users logging in. It'll host the web interface. It'll control jobs going out to the computers on the grid and a lot of other things, actually storing the code that actually gets run. Be able to display the job progress for the jobs that are going on through the web interface. And same thing again, good user interface, easy to use, and that share, be able to control things.
Some of the technologies that we're going to be using for our project is, first of all, BOINC, which is our system of chopping up the programmed jobs that are submitted to the grid and then farming them out to all the different volunteers on our system. We want to be able to use the internet browser to access the web interface, to be able to upload jobs and monitor jobs. High-speed internet just for large files and returning the data that they've completed after running this simulation, and obviously a personal computer which runs the client for our system. This is a little graphical representation of how BOINC works, which BOINC is the backbone of the server system, like farming out all of our jobs and everything. First of all, the volunteer is going to get the instructions for a particular job, and that will send also the application and input files. It also includes what output files they're going to need to return and the time allotted for that job. 3 here is the volunteer actually computes the job and gets all the output files. It's going to then send these output files back to the server and then report that it's finished. The preliminary architecture for how the system is going to work is obviously the server set up with BOINC, farming the code out to everyone. We want the volunteer client interface, which is just getting that small set of data, running the client, or running the code, and then returning the results. And our researcher client is the web interface, which will allow the researcher to log on, see how much they've contributed to the grid, which gives them credits to run their own code, which they can upload. It lets them see currently run jobs, get the data back from that job in the finished results, and basically anything they need to see